Calculate the mass by volume percentage when 70 grams of solute is dissolved in 490 ml of solution. Do it. Yes, you done? Hanan and Sarah, you done this one?
No, sir, I'm doing.
This is very simple and direct formula based question. Mass by volume. Yes, you Saad, you done?
No, sir.
Hmm?
No, sir. I'm doing.
Noted fast. Yes, you done?
Yes, sir.
Yes, sir.
Okay, so what's the answer? Yes, you, Hanan and Sarah. And Saad, what's your what is your answer? Aram, turn on your camera. So what is your answer? Yes.
100 by 7%.
Yeah. It is 70 upon 490 into 100. 0 and 0 will cancel out. And this one 7 ones are and 7 sevens are. You have to divide it 100 upon 7. And that you will get 14 point something. Okay, 14.28 now.
Yes, sir.
Okay.
Yes, sir.
So this is very simple question. Okay, next question that we're going to have here is Here we have this question. Tell me the answer for this question, please. What should be the answer for this question? What should be the answer for this question? Yes, Sarah and Hanan, could you answer me this question? Yes, Yuanam.
Sir, sample A will freeze at 0 degree since the boiling point of pure water is 100 degrees Celsius. So hence it will freeze at 0 degree, and sample B will not freeze at 0 degree Celsius.
Will it freezes above 0 degree or below 0 degree?
Sir, below 0 degrees.
Below 0 degree. Yes. Pure solvent. Pure solvent means pure water is going to have a, means, for example, a pure solvent is there. There is water, pure water. Okay, pure water. So pure water is going to have, we can simply say here that pure water is going to have boiling temperature of 100 degree. Okay, its boiling temperature is 100 degrees Celsius, boiling temperature or boiling point. Okay, but its freezing and its freezing temperature is 0 degrees Celsius. But you need to keep in mind here is that when we are going to have, just concentrate here. Okay, when we are going to have 100 degree, when we are mixing it something, pure water, and then now it is a solution. Okay, a solution always have, when we have a solution, then there is an elevation in boiling point. Elevation means increase in boiling point, and depression in freezing point is seen. Okay, when we means a solution always have a greater temperature, greater boiling temperature than its pure form, and a solution always have a lower freezing temperature than its pure form. So elevation in boiling point and depression in freezing point is seen in a solution. Okay, elevation in boiling point, and depression in freezing point is seen. Okay, you understood? Yes or no?
Yes, sir.
Okay,
Yes.
so note this one. And then you have to write the proper answer. You given two sensor level A, B. A boils at 100 degree and B boils at 102 degree. Sample will not freeze at 0 degree. Will not freeze. So B sample will not freeze. A sample will freeze at 0 degree. And comment why? Because a pure solvent always have a greater temperature than its. Okay, so note it down, please. Done? Okay. Here question comes that what are the favorable qualities of gold and when it is alloyed with copper or silver for the and why it is okay, why it is alloyed means why we mix, like you know that pure gold is 24 karat gold, okay, but when we buy the jewelries, and jewelries are made up of 24 or 22 karat gold, sorry, why they are mixed with some impurities or some other metals like copper and silver, why they are mixed with them? Can anybody answer me this question? Why we mix this one? Hmm? Do this one, please. Yes, you noted.
Yes, sir.
Okay, what is the answer? What is the answer? Hmm? Tell me what is the answer?
Can I say?
Yes.
Gold is a very soft type of metal, meaning that we cannot make ornaments with it because since it's soft, it's hard to make jewelry out of it. So we
Yeah.
will mix it
Yeah.
with copper or silver.
To make it hard, na? Okay.
Yes, sir.
Yeah. Simple, very simple is that gold is soft metal. It is not so strong. So it can easily be bent or it can easily break. Okay. So to make it hard and fit for the jewelry purpose, we add some impurities or some other metals to it, and this is what we call. Okay, so note the answer here for this question. A very simple answer. Note this one. Done?
Yes,
Yes,
sir.
sir.
Okay, next question. What do you mean by the sonorous and ductile? Tell me, what do you mean by
So
sonorous and
sonorous,
ductility?
sonorous means they make sound when they hit each other.
Okay. And what is ductile?
Sir,
Ductile, they can
ductile.
be,
Yeah, yeah. Okay. Anam, you? Yes, Anam, you were answering.
and ductility means they can be made into wires.
Is the same, is the same answer for you, Anam?
Yes, sir.
Yes, they can be drawn into thin wire. Okay. Under which condition would you classify this element and other characteristic that you expect the element to possess? Note this question. Let you write this question first in your notebook because we done this chapter, so we need to consider the clear questions. Okay, so note this one. Done. Done the question.
Yes, sir.
Okay. So what should be the answer for this question that we were discussing? That tactile sonorous are one which produce sound. Okay, and the ductiles are those one that simple. Ductiles are those that uh, can be drawn into thin wire. Means the metal that can be drawn into, and these elements and this type of elements we call them metals. Okay, because metals possess this type of property. So if the question comes that how will you characterize these type of elements? So these elements are so it is asking that under which category would you classify this elements? This element is an element. It is about talking about an element which is sonorous, which can produce sound on striking and are ductile. So under which condition will you classify this element? We can classify this element as metal. And what other characteristics do you expect for element to possess? That it can be a good conductor of electricity. Okay, and it has high melting and boiling point, and it might have high melting and boiling point. Mercury can be liquid, but we can say we will use word. It might have because there are so many metals that are okay that have low melting points. So it might have high melting and boiling points, and melting point is important. Okay, and good conductor of electricity. It must have. It is all metals are good conductor of electricity. There is no exception that we don't have any metal which is metal but not a good conductor of electricity. All metals are good conductor of electricity. Okay, so you can write this type of answers. So we can have this element is another possessed by this element is that it may be lustrous, it may be shiny, malleable, that it can be drawn into thin sheet, heat and electrical conductivity. It will conduct heat and electrical conductivity might be there. So please note it down. Yes, you done?
Yes, sir.
Yes, sir.
Okay, next question. So if what do you mean by the volatile and non-volatile compounds? Like for example, and what are volatile compounds and what are non-volatile substances? Components or non-volatile components. So you have to give the example for each of the following questions. So here are the questions and you need to answer these. Give an example for the mixtures having characteristics, following characteristics, suggest a suitable method to separate them, these mixtures. So we are not asking for the separation because separation is not in our syllabus. A volatile and a non-volatile compounds. You have to answer that what are volatile compounds and what are non-volatile. Yes, tell me. Volatile compounds are those compounds that can easily boil, that have low vapor pressure. Okay, low vapor pressure they are considered to be as volatile compounds, and that have very high vapor pressure means they have very high melting point. Low vapor pressure means that if they have low vapor pressure they can boil easily. So we can simply say that volatile compounds are those compounds that has low melting points, sorry, low boiling points, and non-volatile are those that have high boiling points. Okay, high melting and boiling points you can write. Okay, and the next one is the two volatile components with appreciable difference between their boiling points. Means appreciable difference between in boiling points. We can have two volatile compounds, but it is not asking that how can we separate them. Actually, we can separate them by distillation and two miscible liquids. So actually, this question is about how can we separate them. So just if the separation means in your school, is it being taught in the schools because it has been deleted from the NCRT? But if in schools it has been done, then we can go through it. Separation techniques not taught. Okay. So just one word answer, you can write these answers. That is very simple. That how can you separate them? At least you must know for the knowledge. Okay. That how can you separate them? You noted the question, everyone? Aram, why have you turned off your camera? Are you start doing something else? Then
No,
why
sir.
you turn off your camera? So do this one. Note this one. Evaporation. First, the answer for the first question is evaporation and distillation. You can separate. Second is distillation. Third one is separation by separating funnel, sublimation, and last one is chromatography. Done?
Yes, sir.
Yeah. If this question came in your examination and it is important, it might came. Okay. So here we have this one. Sucrose, which is known as sugar, they are obtained when we have the sugarcane juice and we crystallize it in the centrifugation machine along with the beetroot. Okay. Shakargandhi recorded are mixed together. Okay. Will it be a pure substance or a mixture? Means the crystal that are obtained from the sugar. Okay. So by the crystallization, will it be a pure substance one, which is compound or element, or a mixture? Give reason for this for your answer. Will it be a pure substance or a mixture? Have you noted the answer? Question. And then tell me the answer for this question. Now, can you tell me, can anybody in the class can tell me that what are pure substance and what are impure substance? Pure and impure substance? What are pure and impure substance? Tell me fast. What are pure and impure substance? Hmm?
Your substances are of a single atom.
Pure substance
Is of like a single atom or molecule,
yeah, it can be
while
element.
in
Yeah.
while impure substances are made of different types of atoms or molecules.
We are not talking about the atom. When two or more substance mixed together in not in a, without any proportionate manner, okay, without any proportionate manner, or they are physically bonded, they are considered to be as impure substance. And in the impure substance, the particles or the constant shows their property after the change. Yes, Anam. So will it be a pure substance? Sugar crystals that are formed, whether it is a sugar crystal or whether it is a sodium chloride crystal, is it a pure substance or an impure substance? Yeah, we'll consider them pure because sugar crystals or salt crystals have a particular formula, that is NaCl for the salt crystal, and sugar crystals have the formula that is sucrose, that is C6H12, sorry, C12H22O11. So the compound that is going to have its own formula that is considered to be as pure substance. Like water has a pure formula H2O, carbon dioxide has a formula CO2. So they are all pure substance. And the one which is not having pure substance, or we will consider it like simple, that the substance that don't have their formula, like sugar solution don't have any formula. There's a mixture of water and sugar, but don't have any fixed formula. So that's why it is considered to be as impure substance. Okay, so note it down here. Note it down here. Noted? Yes or no?
Yes, sir.
Okay, what is Tyndall effect? And give some example of Tyndall effect. What is Tyndall effect? Yes, Sarah. What is Tyndall effect? What is Tyndall effect? You are muted. Sarah, you are muted.
Yes, sir.
What is Tyndall effect? Okay, yes, you Hanan. What is the Tyndall effect?
Tyndall effect is a phenomenon where the particles of collide are scattered and it becomes a beam of light.
The scattering of light,
Yes, sir.
white light by a colloidal solution or by the colloidal, and that make the light, the path of light visible is known as Tyndall effect.
Yes, sir.
Okay, and the path of light is visible due to scattering of light by the particles of colloids. It is known as Tyndall effect. Okay, understood? Yes or no? Yes or no? Okay, so note it down. Note this one. Note this one, please. What is Tyndall effect? Note it down that the scattering of light by the particles of colloids, the scattering of light by the particle of colloids by the particle of colloid, the scattering of light by the particles of colloids, which make the path of light visible, which make the path of light visible, is called Tyndall effect. Is called Tyndall effect. Note further, Tyndall effect can be seen when Tyndall effect can be seen when Tyndall effect can be seen when light passes through heterogeneous mixtures. Light passes through heterogeneous mixture. When light passes through heterogeneous mixture. Examples: when sunlight passes through, when sunlight passes through, example, when sunlight passes through, When sunlight passes through the canopy of dense forest, the canopy of dense forest, the canopy of dense forest. Here we have a question, one advanced question. Note this question in your copy. Yes, you done? Noted. Done? Yes or no?
Yes, sir.
Okay. Now tell me the answer for this question. Can anybody guess this the answer for this question? This you have been studied in the 8th class also. Yes, why you have been disconnected again and again? So let me explain you that on heating calcium carbonate, what is going to happen? This is the calcium carbonate. When you heat it, it will gives you calcium oxide. This is calcium carbonate. When you heat it, it will gives you calcium oxide plus what? Plus carbon dioxide. Calcium oxide, carbon dioxide. So if I write it in the word that when you heat calcium carbonate, when you heat it, it will gives you calcium oxide plus water. I'm writing the formula also here. Calcium carbonate, when heated, it will gives you calcium oxide CaO plus H2O. And how can you make an acidic and basic solution for these two? For these, sorry, H2O. No, it is not H2O. Sorry. Just a minute. Just a minute. It is carbon dioxide here. Just do a correction here. It is not water. It is carbon dioxide. Carbon dioxide. It is CO2. Okay. Now it is asking that how can you prepare an acidic and a basic solution for this one? So when calcium oxide is treated with water, it will gives you calcium hydroxide. Means when this is treated, calcium oxide, when react with water, it will give you calcium hydroxide, which is basic in nature. It is basic in nature. Okay. And if you mix carbon dioxide to water, it is acidic in nature. It is acidic in nature. So when you mix carbon dioxide to water, CO2 plus water, it will give you H2CO3, carbonic acid, and carbon dioxide side plus water, it will give you carbonic acid, which is acidic in nature. Okay, which is acidic in nature. This is acidic in nature. You have to note this one. This is important question. Done. Done.
Yes, sir.
Okay. Now do this one. One last question. That smoke and fog both are aerosol, and what is the difference between them? Can you answer me this question? Smoke and fog both are aerosol, and what is the difference between them? Yes, Anam, can you answer me this question?
Sir, I think I need some time to think.
Okay. Yes, you, Hanan. Can you answer me this question?
Solid is dispersed in smoke while liquid is dispersed in fog.
Yes, there is a difference between the dispersion medium. Na? Dispersion phase. So when we mix solid in water, well, then it is, sorry, solid in air, like carbon particles, unburned carbon particles when present in the air, that is known as smoke. But when we have water in air, like water vapor, okay, or fog, then it is known as fog. Okay. When we have liquid in air, liquid mixed in air, it is fog. And when solid mixed in air, it is smoke. What both are aerosol. Okay. So this is the difference between the This one. So you have to note the answer for this question. Just a minute. Change of dispersal medium. Note this one. You done?
Yes, sir.
Okay. So that's all for today. We'll meet you in the next class. Thanks for coming, everyone.
Thank you, sir.
Bye-bye. Take care. Zainab, wait for 5 minutes so that the other student may also join. Okay.
Okay, sir.